Let's have a look at how a user accesses a network service, such as a website, in the local domain. For the website to be Kerberos enabled, it requires a DNS-A record. An SPN, in this case http/mysite.a, registered under the service account which runs the site. In this case, service account called mysite.a svc. And Windows authentication enabled with Negotiate or Kerberos only provider. Here we have our client user 1 on PC 1, a DC which runs DNS and KDC, and App1 web server which hosts the mysite.a website. As mentioned previously, the client, KDC, and website server's system time discrepancy needs to be less than 5 minutes. The client types the URL in a browser and hits enter. The browser looks up the website in DNS and sends access requests to the server hosting the website. Here is the initial GET request in Network Monitor. If anonymous access is not enabled, the server responds with HTTP status code 401 unauthorized. The client then starts the Kerberos authentication process for the specific service. Here is 401 unauthorized response in Network Monitor. Before it attempts to connect to KDC TGS, the client checks its credentials cache for the website service ticket. If it doesn't have it, the client checks the cache again for a valid TGT. If it finds a TGT obtained during the login process, the client takes the corresponding KDC session key and uses it to encrypt the pre-authentication data, and then sends both the authenticator and TGT to KDC TGS, along with the SPN of the target service website. Here is the service ticket request in Network Monitor. We see a TGT, an authenticator, and the website SPN. The KDC TGS receives the service ticket request, decrypts the TGT with its Kerberos service key, extracts the KDC session key, decrypts the authenticator with the session key, and evaluates the authenticator. If the authenticator passes the evaluation, KDC TGS generates a new service session key, which will be used in the user to website service communication. KDC TGS responds to the client's request by sending one copy of the service session key, encrypted with the KDC session key, which is shared with the user. It also sends another copy of the service session key together with the user's PAC sign with Kerberos service key in the new service ticket. The service ticket now becomes the client's responsibility to manage. We'll see the content of the ticket in a moment. Here is the TGS response in Network Monitor, and we see the service ticket is included. Now the client sends an application authentication request, including the service ticket, to App1 web server. The user receives the response from KDC TGS, uses its copy of the KDC session key to decrypt its copy of the web service session key, and stores it in its credential cache, together with the web service ticket. The user then creates a new authenticator encrypted with the web service session key, and sends it together with the service ticket to App1 web server as an application authentication request. Here is the request in Network Monitor. We see that the authorization field is set to negotiate. Mutual authentication is required. Encryption algorithm is set to RC4, since AES support hasn't been enabled. And we see the authenticator encrypted with the session key, shared between the user 1 and the website service account. The website service receives the authentication and access request from the client. It first decrypts the service ticket using its service key to read the request and PAC and to obtain the service session key. It then uses the service session key to decrypt the authenticator and evaluates it. If the authenticator passes the test, the service initiates mutual authentication. Basically, the service uses the session key to encrypt the time from the user's authenticator and returns it in a reply for the user to verify the service. Here is the response in Network Monitor. The client was successfully authenticated and the client's timestamp is sent back for server authentication. This is the client's timestamp from the request, encrypted with the web service session key. When the user receives the application authentication response, it decrypts the web services authorization data field with the web service session key and compares the time returned by the service with the time from the original authenticator. If they match, the client knows that the service is genuine. Here we see a Kerberos logon event in App1's security log. We see the service ticket in the user's credential cache on PC1, and we see it's encrypted with RC4, since AES hasn't been enabled. Finally, the service verifies and updates the pack and then creates an access token. After the server authenticates the client using Kerberos authentication, the user's pack is taken from the service ticket and used to create the user's access token. The service verifies the pack signature through a NetLogon call to a domain controller, but only if delegation is enabled.